Okay. So let's look at classifying these angles here. If I look at this angle and I want to name it, remember there's several ways I can name it, and I'm going to name it both ways. The first one is my 3-point name, and so that can be angle RTS. Remember the vertex has to be in the middle, or I can name it angle STR. Vertex is in the middle. Since it's a single angle, I can also name it angle T and just use the vertex. The measure of this angle, because I'm looking at this symbol right here, that means perpendicular, that means a right angle, the measure is 90 degrees. Therefore, since it's a 90 degrees, it is a right angle. Remember, all right angles are 90 degrees. So here we're going to look at the second one. This is a straight angle. And even though it looks like a straight line, we talked about how two opposite rays, if you have ray XS and ray XN, they make an angle. Remember, I can draw any random angle that's a combination of two rays. These rays just happen to be opposite rays, which form a straight line. So I can still name this with my 3-point name or my vertex name. So my 3-point name for this one is going to be either angle NXS, great band from the 80s by the way, NXS, or SXN. Again, the 3-point name, vertex in the middle. Since it's a single angle, I can also name it by its vertex name, which is angle X, because there are no other angles attached to it. Now, a straight, this is going to be a straight angle. The measure of this angle is 180 degrees because it's a straight line. If you go from here to here, that's 180 degrees, okay? So we call this a straight angle because it is basically a straight line. So that is a straight angle. All right, so let's look down here at angle bisector. Now, when two angles have the same measure, they're said to be congruent. And we've talked about congruent. Congruent is same size, okay? Congruent is same size and same shape. So that means not only is it the same size, it's the exact same shape. And there's a difference between congruent and equal. There's a difference between congruent and equal. Congruent and equal are not always the same thing, because two things can be equal, but they may not be congruent. Think about a 20-ounce bottle of Coca-Cola and maybe a 20-ounce bottle of Pure Leaf iced tea. The two bottles have 20 ounces, but they're equal in measure, but the two bottles are not the same shape. So when we look at them, you would have something like this for the Coke bottle. For the 20-ounce bottle, it kind of looks like this. I know that looks more like a dead fish than a soda bottle. But say you have your soda bottle here, you got your Coke bottle, and then you've got the other bottle from the other company, which is longer and narrower, but they're both 20 ounces. Okay, this is the tea bottle. They are not the same shape, but they have the same volume. They have the same measure. I know those are beautiful drawings, and I know you wish you were able to draw like me. Don't be jealous. So now let's look at angle bisector. So an angle bisector is something that creates congruent angles. It is a line, a ray, or a segment that divides an angle into two congruent angles, so two equal halves. So let's draw a generic angle here. Okay, I'm going to draw angle number 1. Okay, let's bisect this angle with a line. If I draw a line right through here, and that creates two congruent angles. That's how we mark angles congruent. They have the same number of arcs. That is an angle bisector. That line is an angle bisector. Okay, let's draw another angle. We can make this one go this way. And now, instead of bisecting it with a line, I'm going to bisect it with a ray. So I'm going to draw that ray here, and that creates two congruent angles. Again, that's the way we mark angles congruent. They have the same number of arcs. So that's if we bisect with a ray. We can also bisect with a segment. So let me draw another angle here. And now I'm going to bisect this angle with a segment. So the segment is going to start here, kind of go here. It's just a segment. And again, those two angles are congruent. So that's what an angle bisector is. It is a ray, line, or segment that cuts an angle in half. So using that idea, we come down here and it says ray FG bisects angle EFH. Find the value of x for each of the following. So it tells us that FG, ray FG, bisects angle EFH. So let's find EFH. EFH. Ray FG bisects. So we're going to mark these congruent. That means angle EFG, the measure of angle EFG is going to equal the measure of angle GFH. So the measure of this angle EFG is equal to EFH. Now when you use congruent symbols, you would say that they are congruent to each other. That's how you show congruent. And I know y'all have seen congruent before. So using that idea, we're going to come down here. We know EFG is 5x minus 10 and GFH is 3x plus 25. Well, we know those two angles are equal because they're getting bisected. So let's set up the equation. I know that 5x minus 10, which is EFG, has to equal 3x plus 25, which is GFH. So I'm going to solve it. I'm going to move the 3x. That's going to be my first step. Your first step may be a little different. I've got 2x minus 10 equals 25. My next step, I'm going to add the 10. So 2x equals 35. And then I'm going to divide both sides by 2. So x equals 17.5. If you want to check and make sure your answer is correct, you can take the 17.5, plug it in for x in both angles, and see if you get the same answer. If I were to do that, I'm going to do EFG first. 5 times 17.5 minus 10 is EFG. And 3 times 17.5 plus 25 is GFH. Let's see if they're equal. We have 85. We have 87.5 minus 10, which is 77.5. And then we have 55.5 plus 25. Let's see. Sorry, I apologize. It's not 54. 3 times 17 is 51. So 52.5 plus 25 equals 77.5. Check. We got it right. So I found the answer, plugged in to make sure the angles are equal. All right, so let's look at the last example. On the last example, I'm going to set it up for you, and then you need to solve it. So GFH, which is this one, is 3x plus 20. And EFH is 4x plus 80. Now be careful here. Where's EFH? EFH is the entire thing, right? So what do I do? Basically, the GFH, they've given me this angle right here. They've given me that angle. And what other angle have we gotten? Well, we've been given this big angle. So if I'm given the whole and given one part, how do I find the other one? Well, I subtract. Well, the question is, what do I make it equal to? Well, since this ray cuts this angle in half, doesn't that mean that 3x plus 20 and 3x plus 20 would work for both angles? If GFH is 3x plus 20, that means that EFG also has to be 3x plus 20 because it bisects it, it cuts it in half. So that means 3x plus 20 plus 3x plus 20, right? This one plus this one is going to equal the entire angle, which is 4x plus 80. And from there, you solve it out, okay? And when you solve it, you combine your like terms, solve for x. Once you have x, if you want to make sure, up here in the instructions, it just says find x. It doesn't say anything else. You need to find x, then you plug it back in and make sure that EFH is twice as big as GFH, because remember, EFH is the whole thing. We know that FG, ray FG